So in part A of this question, we're told that the number of hours of sunshine each day, which is denoted by Y, for the month of July at Heathrow are summarised in the following table. So we're given the hours and then an interval of hours. So for example, this column here, it lies between 0 and 5, 5 and 8, and so on and so forth. And then we're given the frequency. So how many values appear in each interval. So you can see between 0 and 5, there are 12 observations, 5 and 8, there are 6 observations, and so on. So we're told that a histogram was drawn to represent these data. So we know that a histogram is a shape that looks a little bit like this. So I've drawn my axis here, and then we have like this. So for example, so this would be sort of like the histogram we would be dealing with for this question. But that's all extra information, we don't need to worry about that. So we're told that the 8 to 11 group was represented by a bar of width 1.5 centimeters and height of 8 centimeters. And what we're asked to do is we're to use all this information to find the width and the height of the 0 to 5 group. So the Y between 0 and 5. So how are we going to do this? So there's a few key pieces of information that we need to recall. So we're given the frequency and we know the width of this group between 8 and 11. So we can therefore work out the frequency density. And then we can use this equation here where we take one frequency density and divide it by the second frequency density. And we can then use the height of both groups. So we're going to start off by working out both the frequency densities. So we're going to say that frequency density 1 is going to correspond to the 8 and 11 group, and frequency density 2 is going to correspond to the 0 to 5 interval. So therefore, we can now use this equation here and work these out. So we'll just note down the information. So we have that the frequency of this group is going to be 8, and the frequency of the second group is going to be 12, reading them off our table. And then what we can also do is we can work out the width. So the width of the first group is going to be equal to 11 minus 8, which is 3. So we'll have 11 minus 8, which is equal to 3. And then the width of the second group is going to be equal to 5 minus 0, which is equal to 5. So we're now in a position we've extracted all the information from the table, and we have it here. And we can now use this equation here to work out both the frequency densities. So we can say that frequency density 1 is going to be equal to 8 over 3. And we'll have that frequency density 2 is going to be equal to 12 over 5, where we have read these numbers from the information we have wrote here. So the next stage is going to be using this equation here, where we use both the frequency densities and both the heights. So we'll have our equation as follows. We will have the frequency density of 1, which is 8 over 3, and we divide that by the frequency density of 2, which is 12 over 5. And we recall in the question that we are told the height of the 8 to 11 group, and we want to work out the height of the 0 to 5 group. So therefore the first height is going to be 8 centimeters. So we have 8, and we divide that by the height 2, which we want to find out. So let's denote that by height 2 there. So we can rearrange this, and we'll have that height 2 is going to be equal to 12 over 5 multiplied by 8, and then we're going to divide this by 8 over 3, and putting this into our calculator, this comes out as 7.2 centimeters. So therefore we have worked out the height of the group, and we now want to work out the width of the group. So how are we going to do this? So we know that the width is going to be in ratio to the width of the interval. So we have that the width of the 8 to 11 group is equal to 1.5 centimeters. But then the width of the interval as such is actually going to be 11 minus 8, which is 3. So then we can use ratios to work out what the width will be for our 0 to 5 group. So therefore, dividing this down, we then know that for one interval it's going to be 1.5 over 3. So therefore, for the 0 to 5 group, we're going to have 1.5 over 3 multiplied by 5, which is going to be equal to 5 over 2, and that is in ratio to the width of 5. So therefore, we can conclude that the width is 2.5. So we know that 5 over 2 is equal to 2.5. So therefore the width is 2.5 centimeters. And this goes along with our height of 7.2 centimeters. So in this question, there was 3 marks available. We receive our first mark for getting to this stage here, where we had an equation to find the height of the 0 to 5 interval. We then receive our second mark for correctly getting the height, and then we receive our third mark for correctly achieving the width, which was 2.5 centimeters. So in part B of the question, we're asked to use our calculator to estimate the mean and the standard deviation of the number of hours of sunshine each day for the month of July at Heathrow. And we're asked to give our answer to 3 significant figures. So we want to find the mean, and we want to find the standard deviation. So the information we need to do this is we need the midpoint. So writing this down here, we need to find the midpoint of each interval. So therefore, we have the 0 to 5 group. The midpoint is going to be 2.5. Then we have the 5 to 8 group. The midpoint is going to be 6.5. We then have that the midpoint is 9.5 for the 8 to 11 group. And then for the 11 to 12 group, the midpoint is going to be 11.5. And then finally for the 12 to 14 group, our midpoint is going to be 13. So now we've worked out these midpoints and we know the frequencies. So I'll write the frequencies in as well. So we have 12, 6, 8, 3 and 2. So these are the frequencies. And what we're going to do now is we're going to make use of our calculator, and I will now show how we do the calculation. So everyone will do this differently on different calculators, but for me, I put my calculator into stats mode. I then turned the frequencies setting on, and I then was presented with a table where I could enter 2 columns. I entered the first column, which was all of my midpoints, and then the second column, I entered all of our frequencies, and from there, I then went into the stats menu, and it let me select different options. So it let me select things like the number of entries, n, and then the mean and the standard deviation. And I then clicked these buttons and they presented me with the following results. That the mean is going to be equal to 6.63 centimeters, and the standard deviation is going to be equal to 3.69 centimeters. And we've therefore completed the question. In this question there was 3 marks available. We receive our first mark for working out the midpoint. We then receive our second mark for working out the mean, and we receive our third mark for working out the standard deviation correctly. So in part C of this question, we're told that the mean and the standard deviation for the number of hours of daily sunshine for the same month in Herne are 5.98 hours and 4.12 hours respectively. And we're also told that Thomas believes that the further south you are, the more consistent should be the number of hours of daily sunshine. And we are asked to state, giving a reason, whether or not the calculations in part B support Thomas's belief. So we need to take into account what information we have already. So we have for Heathrow that the mean, so we'll denote that by mu, is going to be equal to 6.63, and the standard deviation, noted by sigma, is going to be equal to 3.69. And then we're given further information here for Hearn, and we have that the mean mu is equal to 5.98, and the standard deviation is equal to 4.12. So we're told that Thomas thinks the further south you are, then the standard deviation should be lower. So we're told that Thomas believes that the further south you are, the more consistent should be the number of hours of sunshine. So we know that for a lower standard deviation, data will be more consistent. So from this point, we can then say that our two standard deviations are 3.69 and 4.12. So therefore, the number of hours of daily sunshine is more consistent at Heathrow. So now we need to think about the geographical locations of each place. And we know that Hearn is further south. So therefore, this goes against Thomas's belief. So therefore, Thomas's belief is not supported. So writing this down, we have, but Hearn is further south than Heathrow. So therefore, Thomas's belief is not supported. This question was worth 2 marks, and we achieved the first mark for stating that the data is more consistent at Heathrow, and we know this because of the lower standard deviation, and then we receive our second mark for stating that Hearn is further south than Heathrow, and therefore Thomas's belief is not supported. So in part D of this question, we're asked to estimate the number of days in July at Heathrow where the number of hours of sunshine is more than 1 standard deviation above the mean. So we recall that for Heathrow, the mean mu is equal to 6.63, and we have that the standard deviation denoted by sigma is equal to 3.69. So we're asked to work out the number of hours where the sunshine is more than 1 standard deviation above the mean. So we must first work out what 1 standard deviation above the mean is. So writing this down, we're going to have that 1 standard deviation above the mean. This is going to correspond to mu plus 1 lot of sigma, which is equal to 6.63 plus 3.69, and putting that into our calculator or adding that up in our head, this comes out as 10.32. So then we remember from our data that we're given lots of intervals, and we know that all the observations in the 11 to 12 and 12 to 14 pool are going to be greater than 10.32. And we know that all the observations in the 11 to 12 and 12 to 14 categories are going to be greater than 10.32. So therefore, writing this down, since 11 is greater than 10.32, we have that all the observations in the 11 to 12 and 12 to 14 group must be greater than 10.32. And we know that these are 3 and 2 observations respectively. And then we also have the group, and we're going to note it down here, which goes from 8 to 11. So we know that some of these observations are going to be less than 10.32, but we know that some are going to be greater than 10.32, or some, in fact, could be greater. We don't know this for sure. So what we need to do is we need to estimate this. So writing this down, we need to estimate how many observations are in this group and, where and is very important, and are greater than 10.32. And we can do that with the following formula. So we'll have that 11, which is the higher end of the group, and then we take away our critical value, so to speak, so 10.32, and then we divide this by 3, which is the width of the interval, with 8 minus 11, and then we multiply it by the lower end of the interval, which is 8. And then putting this into a calculator, this comes out as 1.8. So therefore, we estimate that there is 1.8 observations which are greater than 10.32. So therefore, our total number of observations is going to be 1.8 plus 3 plus 2. Recalling that 3 and 2 came from the other intervals, 11 to 12 and 12 to 14. So therefore, our total number of observations are going to be 6.8. And what we can do is we can then round to 7, as this is a whole number of days. So we can conclude with 7 days. And in this question, there was 2 marks available. We receive our first mark for working out 1.8 using this formula, and we receive our second mark for concluding with the correct answer of 7 days. And we achieve that by adding our observations from the intervals where there is frequency of 3 and 2. So in part E of the question, we're told that Helen models the number of hours of sunshine each day for the month of July at Heathrow by this normal distribution here. So we have that the mean is going to be denoted by mu, which is going to be 6.6. And we have that the standard deviation, so sigma, is going to be 3.7, and here that the variance is 3.7 squared. And what we're asked to do, we're asked to use Helen's model to predict the number of days in July at Heathrow when the number of hours of sunshine is more than 1 standard deviation above the mean. So how do we do this? So we must find our critical value for a normal distribution. So we can do this by using the following formula. So we'll have that our critical value z is going to be equal to x minus mu divided by sigma, where x is going to be the number that was predicted in the previous point, so that would be 10.32. So we'll have 10.32 and we'll subtract 6.6, and we then divide this by 3.7, and putting this into a calculator, this comes out as 1.0054, and then we want to find the probability that x is greater than 10.32, and then what this is going to be equal to, because we can then substitute in our critical value, we'll have the probability of x being greater than 1, which is also going to be equal, using our knowledge of manipulating probabilities, we'll have 1 minus the probability of x less than or equal to 1, and then we read this off the normal distribution table, and this is going to be equal to 1 minus 0.841, and so on and so forth, but rounding out to 3 significant figures, we'll then have that this is going to be equal to 0.159. So then we are asked to work out the number of days predicted. So therefore, the number of days is going to be equal to 31, since there is 31 days in the month. And then we multiply that by 0.159, and that comes out as 4.9 days. In this question, there was 2 marks available. We receive our first mark for working out the probability, which was 0.159, and we then receive our second mark for correctly working out the number of days, which was 4.9. So in part F of the question, we're asked to use our answers to part D and part E to comment on the suitability of Helen's model. So we have that part D gives us a mean of 6.8 days. So writing that down, part D, we have that mu is equal to 6.8 days, and then part E, we have that it is going to be mu is equal to 4.9 days. So therefore 6.8 is not equal to 4.9, which implies that the model is not suitable. So in this question there was 1 mark available, and we receive it for making this statement here about the model not being suitable due to the fact that 4.9 is not equal to 6.9. So in this question we're told that a meteorologist believes that there's a relationship between the daily mean wind speed, denoted by W and measured in knots, and the daily mean temperature, denoted by T and measured in degrees Celsius. We're told that a random sample of 9 consecutive days is taken from past records from a town in the UK in July, and the relevant data is given to us in the table below. So we can see one row of the table giving us the temperatures and one row of the table giving us the daily mean wind speed. So we're told that the meteorologist calculated the product moment correlation coefficient for the 9 days, and the value that they obtained was R is equal to 0.609. So in this question we are asked to explain why a linear regression model based on these data is unreliable on a day when the mean temperature is 24 degrees Celsius. So we know that linear regression requires us to extrapolate data. This is something which we know is unreliable, and we know that we do this to make predictions about other data. But the caveat that comes with this is that it's unreliable. And we know that we have to extrapolate since no data is given for 24 degrees Celsius. We know that extrapolating can be unreliable. Hence, a linear regression model will be unreliable. In this question there was 1 mark available, and we received this for a statement here when we spoke about extrapolating being unreliable. So in part B of this question we're asked to state what is measured by the product moment correlation coefficient. So we know that the product moment correlation coefficient measures the linear association between 2 variables. In our case, we have the linear association between daily mean wind speed, which is denoted by W, and also the daily mean temperature, which is denoted by T. In this question there was 1 mark available, and we received it for stating the linear association between the wind speed and the temperature. So in part C of the question we're asked to state hypotheses and test at the 5% significance level whether or not the product moment correlation coefficient for the population is greater than 0. So we start off by noting that we're testing at 5% significance level. So we have that alpha is going to be equal to 0.05. And what we now must do, we must state a null hypothesis, so H0, and then we'll have an alternative hypothesis, H1. So we're asked whether or not the product moment correlation coefficient is greater than 0. So this means that our null hypothesis is going to be that this coefficient, and we'll denote it rho, is equal to 0. And then we're going to have a one-sided test. And we have a one-sided test because we are just checking to see if the product moment correlation coefficient is greater than 0. So that means since we're not dealing with anything less than, this means we're going to have a one-sided test. So that means we're going to have that rho is greater than 0, and that's going to be our alternative hypothesis. So to find the critical value, so note this down here, critical value. So to find our critical value, we're going to use the product moment correlation data table in the formula sheet. So we have this table and the information we need. We need n, so how many samples we have, and we need alpha. So we know already that alpha is 0.05, And looking back at our question, we were told that a random sample of 9 consecutive days is taken. So that means that n is equal to 9. So therefore, from table, the critical value is going to be equal to 0.5822. So now what we need to do is we need to compare our critical value to the coefficient which was given to us in the question. So we were told at the beginning, we were told that R was equal to 0.609. So therefore, we have that R being equal to 0.609, that is actually greater than our critical value of 0.5822. So for this reason, we reject H naught, and this means that we can conclude that the product moment correlation coefficient is greater than 0. So therefore, we've completed the question, and we're now going to take a look at where we received our 3 marks. So we received our first mark for stating our hypotheses clearly, that's H0 and H1. We then receive our second mark for correctly finding the critical value from the table in the formula sheet, and we then receive our third mark for knowing to reject H0 and concluding that the product moment correlation coefficient is greater than 0. So that's where we receive our third mark there. So in part D of this question, we're told using the same 9 days, a location from the large dataset gave T bar equal to 27.2 and W bar equal to 3.5. So we're asked, using our knowledge of the large dataset, to suggest the location that could give rise to these statistics. So, large dataset. So what do we know? We know there's various places, we know there is various locations in the UK, and then there's 3 locations worldwide. So we're first going to say that, well, this temperature 27.2, is this going to be in the UK? We can look at the data we're given already. All the data in the UK in July, the temperature ranged from around 13 to 19. So therefore, we can say that this will not be the UK, since the temperature is too high. So that's us excluded the UK. This means we have 3 more locations. So our options are Perth in Australia. Our next option is Beijing. And our final option is Jacksonville. So we can exclude Perth, since when we are in the month July, it will be winter there. And therefore it won't be that hot. And then we know that we have low wind. And we know that value of 3.5 is low. And we know that Jacksonville is next to the sea, and Beijing is not. So therefore, the fact that the wind is low implies that not near the sea. Hence, we therefore know that Beijing is very much inland. So therefore, we suggest that the location is Beijing. So in this question, there was 1 mark available, and we received this 1 mark when we suggested that this location that would give rise to these statistics was Beijing. So in this question, we're told that a machine cuts strips of metal to length L, which is measured in centimetres, where L is normally distributed with standard deviation of 0.5 centimetres. We're told that strips with length either less than 49 centimetres or greater than 50.75 centimetres cannot be used. And we're told that 2.5% of the cut lengths exceed 50.98 centimetres. And what we're asked to do, we're asked to find the probability that a randomly chosen strip of metal can be used. So summarising the information we have, we're told that we have a random variable and we're going to denote it by L. And we know that it has standard deviation of 0.5, so therefore writing it in normal distribution form here, we have the mean mu, which is something we may potentially need to work out, and then we have that the variance is going to be the standard deviation squared. So then what else are we told? So we are told that the probability that the length is greater than 50.98 centimeters. And we're told this when we're told that given 2.5% of the cut lengths exceed 50.98. So therefore we write 2.5% in decimal form, which is going to be 0.025. So what we need to do, I'll just write it down here. So our first step is going to be to find the mean, and we denote it by mu. And then our second step is going to be then to find the probability. And what probability do we want to find? Well, we want to find the probability that the length is between 49 and 50.7. So put this in brackets here just to note it down for later. We want to find the probability that the length is between 49 and 50.75. So first of all, the first step we need to find the mean mu. And how are we going to do this? So we're going to use z-scores. So we know that our z-score is going to be equal to x, take away the mean mu, and we divide that by the standard deviation. So what is our z-score? So we know that for 2.5%, we want to find everything that is to the left of our point 2.5. So we know that this can be found on the distribution table by doing 1 minus 0.025, and that is equal to 0.9750. So then we look up this value, 0.9750. We look up that on table, or do it on the calculator. And this means that our z-score, looking up on the table, is going to be 1.96. So therefore, we can say that 1.96 is going to be equal to 50.98, and we take away mu, and then we divide this by our standard deviation, which is 0.5. So therefore, rearranging this, we're going to have that 50.98 minus mu is going to be equal to 1.96 times 0.5. And then rearranging this one step further, we're going to have that mu is going to be equal to 50.98 minus our other side, which is 1.96 multiplied by 0.5. We can then put these values into our calculator, and we have that mu is 49.97, and we round that to 50. So therefore we have that mu is equal to 50 centimeters. So then what we can now do, we have our distribution here. We can now rewrite it with our now known value of mu. So therefore we have that L is going to be normally distributed with mu equals 50 and standard deviation of 0.5, so our variance is 0.5 squared. So then now we want to find our probability. So we're going to have that the probability that L is between 49 and 50.75, and we can use our knowledge of manipulating probabilities to say that this is going to be equal to the probability of L less than 50.75, and we take away the probability of L less than 49. So we now think, how do we work these out? So we could put these into our calculator with the information we know, or we could also do it manually. And I'm just going to run through it manually. So we have that the probability of L less than 50.75 is going to be equal to the probability, so we're going to use z-scores again, of z being less than 50.75, then we take away 50, and we divide by our standard deviation of 0.5, and then we put this into our calculator, and this comes out as the probability of z being less than 1.5, which is equal to the cumulative distribution function phi of 1.5, and we then look up this on a probability normal distribution table, and this comes out as 0.9332. And then we can do the same thing for the probability of L less than 49. And this is going to be equal to the probability of Z being less than 49 minus 50 over 0.5. So this time we have a negative, so we have that the probability of Z is going to be less than -2. So then this time, since we have the negative, we're then going to do 1 subtracted the cumulative distribution function of 2. So therefore, this is going to be equal to 1 minus phi of 2, which is going to be equal to 0.0228. So therefore, we can take this number here and this number here and substitute them in here and here. So therefore, we'll have that the probability of L being between 49 and 50.75 is going to be equal to 0.9332 minus 0.0228. And putting this into a calculator and rounding to 3 significant figures, this comes out as 0.910. So in this question there was 5 marks available, and we receive our first mark for knowing to use the information that we were given and putting together the fact that the probability of L being greater than 50.98 was going to be equal to our 2.5% probability. We then receive our second mark for successfully working out what our z-score was, so that was 1.96, and then we receive our third mark for finding that the mean mu was equal to 50. We then receive our fourth mark for then knowing to find the probability that L was between 49 and 50, and then we receive our final mark for working out the correct answer and concluding with 0.910. So in this part of the question, we're told that 10 strips of metal are selected at random, and we're asked to find the probability that fewer than 4 of these strips cannot be used. So in this case, we know that the probability that a strip cannot be used will be equal to 1 take away 0.910, where 0.910 was our answer to part A. So now, if we let x be a random variable, which denotes the number of strips that cannot be used, then we're going to have that x is binomially distributed with n equal to 10, and the probability p is going to be equal to 0.09. And where does 0.09 comes from? We have 0.09 is going to be 1 minus 0.910, which is 0.09. So this comes from this part up here. So therefore, writing that in a more mathematical sense, we have that x is a random variable, and it is going to be binomially distributed with n equals 10 and p equals 0.09. So then what do we want to find? So we want to find the probability that fewer than 4 strips cannot be used. So therefore, that is equivalent to saying we want to find the probability of a random variable x, where x is less than or equal to 3. And we can either do this in our calculator or read it from a table, and this comes out as 0.99. In this question there was 2 marks on offer, and we receive our first mark for correctly noticing and writing out the distribution. So in our case we have a binomial distribution, and then we receive our second mark for using either our calculator or the binomial tables to come to the correct answer of 0.99. So in part C of this question, we're told that a second machine cuts strips of metal of length x centimeters, where x is normally distributed with standard deviation of 0.6 centimeters. And we're told that a random sample of 15 strips cut by the second machine was found to have a mean length of 50.4 centimeters. And we're asked to state your hypotheses clearly and use a 1% level of significance to test whether or not the mean length of all the strips cut by our new second machine is greater than 50.1 centimeters. So we're first going to note down the information we're given. So we're given that n is 15 because we're dealing with 15 strips. We're given that sigma, which is our standard deviation, is equal to 0.6 centimeters. And we're given that our sample mean, which we'll denote by x bar, is equal to 50.4 centimeters. So we're first going to state our hypotheses. So this means we'll have a null hypothesis and we will have a alternative hypothesis, which will be noted by H1. So as we do with these types of questions, we'll have that H0 is going to be our mean mu is equal to 50.1 centimeters, and then our alternative hypothesis. So in the question, we're asked to test whether or not the mean length of all the strips is greater than 50.1 centimeters. So therefore, this is going to be a one-sided test where we test to see if mu is greater than 50.1 centimeters. Just write in here, it's a one-sided test. So before we write out how a random variable is distributed, we need to take into account the standard error of the mean. So this time, instead of using standard deviation in our distribution, we need to use standard error of the mean. This is since we're dealing with a distribution of sample means. So therefore, this is going to be equal to sigma over the square root of n. So therefore, in our case, it's going to be equal to 0.6 over the square root of 15. So then we can then say, if we have a random variable, in this case it's going to be x bar, let that be distributed normally, and we know that the mean mu is going to be 50.1, and this time around our standard deviation is this. So this means that if we square this, we'll have our variance, so we'll have 0.6 squared, and then root 15 squared is going to be just 15. So therefore, we can now move on to try and work out the probability. So we'll have that the probability that our random variable x bar is greater than 50.4. So we're going to use our kind of z-score technique again. So we'll have the probability of z being greater than 50.4 minus mu, which is 50.1. And we divide all of this by our standard error of the mean, which is going to be 0.6 divided by the square root of 15. And then putting this into a calculator, we'll have that the probability of z is going to be greater than 1.94. So then this means that we can find the probability by doing 1 minus the cumulative distribution function of 1.94. We can either do this on our calculators or by referring to a normal distribution table, and this comes out as 0.026. So then what is this value? This is effectively going to be our p-value. So then we have that our p-value, 0.026, is greater than 0.01, where 0.01 is alpha. So then this means, since we've now done our test, we've compared our p-value to the value of alpha, which is 0.01. We therefore conclude, since the p-value is greater than alpha, that we do not reject H0, and we can conclude that there is insufficient evidence that the mean length of strips is greater than 50.1 centimeters. So therefore we've completed this question. We receive our first mark for stating our hypothesis here. We then receive our second mark for successfully writing out how our random variable x bar is distributed. We then receive our third mark for correctly working out the p-value, which in our case was 0.026. And we then receive our fourth mark for saying that our p-value is greater than alpha. Then we receive our fifth and final mark for giving a correct concluding statement. So in this question, we're given 3 probabilities. So we're given the probability of A is equal to 0.35. We're given that the probability of B is equal to 0.45. And we're given that the probability of A intersect B, or otherwise known as A and B, which is given by this symbol here, that is equal to 0.13. And in part A of this question, we're asked to find the probability of the complement of A given complement of B. So the complement symbol is this little dash which appears at the top of the letter. So like I said, we're being asked to find the probability of the complement of A given the complement of B. So we have a formula which we can use for these conditional probabilities, and we know that the probability of A given B is going to be equal to the probability of A intersect B divided by the probability of B. And this time, remember in our question we're looking at the complement, but this in effect doesn't change, and we just replace in our formula our A with A complement and our B with B complement. So therefore, the formula we're going to use is the probability of the complement of A given the probability of the complement of B is going to be equal to the probability of the complement of A intersected with the complement of B, and we divide this by the probability of B complement. So what we can do now is we need to work out all these parts of the formula before we can then put them into our formula. So we first take a look at the probability of the complement of B. So we're told that the probability of B is equal to 0.45. So then the probability of not B, or complement B, is therefore going to be 1 minus 0.45, which is equal to 0.55. And then now we want to work out the probability of the complement of A intersected with the complement of B. And how are we going to do this? So if we have a Venn diagram, so just say like this for example, and we have A and we have B. So just for example, we have A and we have B. So we know that what I'm highlighting in yellow here, that is going to be A intersect B. And then we know that what I now highlight in green is going to be the opposite of this. So this means we can work this green highlighted area out by first working out the probability of the union of A and B, and that is going to be equal to 0.35, which is the probability of A, plus 0.45, which is a probability of B, and then we take away the intersection of A and B, the probability of the intersection of A and B, which is 0.13, and putting this into our calculator, this comes out as 0.67. So therefore, we can then find the probability of not A intersected with not B, or the complement of B, and that is going to be equal to 1, which is the whole maximum probability, and we subtract 0.67 from that, which gives us 0.33. So then just to confirm, the two important numbers here is 0.33 and 0.55. So what we can now do is take these numbers and substitute them back into our original equation. So we'll then have the probability of not A intersected with not B, which is going to be equal to 0.33, and we divide this by the probability of the complement of B, which is 0.55, and then putting this into our calculator, this comes out as 0.6. So therefore we can say that the probability of the complement of A given the complement of B is going to be equal to 0.6. So in this question, there was 2 marks available, and we received our first mark for knowing to use this formula and getting to the stage where we had 0.33 over 0.55, and then we receive our second mark for getting the correct answer. So then in part B of this question, we're asked to explain why the events A and B are not independent. So we know that if the event A and the event B are independent, then we know the following. So we know that the probability of A multiplied by the probability of B must be equal to the probability of A intersect B. So, for our case, we have the required information, so we compute it to see if they are independent. So therefore, we have that the probability of A intersect B from the question is going to be equal to 0.13. And we know that the probability of A is going to be equal to 0.35, and the probability of B is going to be equal to 0.45. So therefore, probability of A multiplied by the probability of B is going to be equal to 0.35 multiplied by 0.45. And putting that into our calculator, we get that that is 0.1575. But then we have that that is not equal to 0.13, where 0.13 is the probability of A intersect B. So therefore, since probability of A intersect B is not equal to the probability of A multiplied by the probability of B, A and B are not independent. So this question was worth 1 mark, and we received this 1 mark for having a fully correct explanation which included the correct probabilities and the comparison between the probability of A multiplied by the probability of B and the probability of A intersect B. So for part C of this question, we're told that event C has the probability of 0.20, and we're told that events A and C are mutually exclusive and the events B and C are statistically independent. And what we're asked to do is to draw a Venn diagram to illustrate the events A, B and C, and we're to give the probabilities for each region. So first of all, we're going to make a few notes to help us frame the question. So what does mutually exclusive mean? So it means that two events cannot happen simultaneously. So therefore, in our case, we have that A and C are mutually exclusive. So this means that A and C cannot happen simultaneously. And then we have that B and C are statistically independent. This just means the same as independent. So writing that down, statistically independent just has the same meaning as independent. So therefore, in our case, we have that B and C are independent. So here I have a box which I'm going to draw my Venn diagram in. So we know that A and C cannot happen at the same time. They cannot happen simultaneously. So this means A will not be connected at all to C. But we know that B will be in the middle because we're already told that A intersects with B. So therefore, I'm going to draw in my 3 circles. So we can see there is sections where these intersect, etc. So I'm now going to label them. So I'm going to do this in purple. So I'm going to label our first one as A, our second one is B, and our third one as C. So first of all, we need to remember back to the question and think about what information we're given. So we're told that the probability of A is equal to 0.35. We have that the probability of B is equal to 0.45. We have that the probability of A intersect B is equal to 0.13. And we're more recently given that the probability of C is equal to 0.20. So first of all, we can see there is one thing which we can just slot into our diagram. So we have the probability of A intersect B is equal to 0.13, and we can see that this is this area here where we have the intersection between A and B, so therefore we can draw in 0.13 here. And then we also know the probability of A, so we can now work out the remaining part of this, which is going to go in here. So that is going to be 0.35, which is the probability of A, minus 0.13. So we'll have 0.35 and we'll take away 0.13. So therefore, in this point, we'll have 0.22. And the next thing we can do, we know that B and C are independent. Hence, we know that this will mean that the probability of B intersects C is going to be equal to the probability of B multiplied by the probability of C. And we know the probability of B and the probability of C. So substituting these in, we have 0.45 and we multiply that by 0.20, and this is equal to 0.019. So we can therefore now look at our Venn diagram, and we have the intersection of B and C is going to be this area here, and we know the value for that, so that is going to be equal to 0.09. And then, like we did for the remaining part of A, we can now fill out the remaining part of C, and that is going to be equal to the probability of C minus this intersection value. So that's going to be 0.20, and then we subtract 0.09. So we therefore have that is equal to 0.11. So our next step is going to be to take a look at this part here. So we know we can work this remaining part out because we have the probability of B and the two intersections there. So we'll have that this one is going to be equal to the probability of B, 0.45. Now we subtract 0.13 and 0.09. And putting this into our calculator or doing it in our head, we get that this is left as 0.23. So then there's one more thing that we need to do. So we've done everything we need to do relating to A, B and C, but we now need to say what's the remainder. We need to fill out what fills this section here. So all around are 3 circles. And we can work this out as follows. We have that the probability of the union of A and B and C is going to be equal to 1 minus everything else. So we're going to add all the other parts. So we're going to have, go from left to right, 0.22 plus 0.13 plus 0.23 plus 0.09 plus 0.11, and then this is going to be equal to 1 minus 0.78, and that is going to be equal to 0.22. So therefore we know that everything else is going to be equal to 0.22. So we'll then just write this in here, and we've therefore completed the question, and we have successfully filled out our Venn diagram. So in this question there was 5 marks available. So we achieved our first mark for drawing out our circles. So we then receive our next mark for attempting to work out the probability of B intersects C, and then we receive our third mark for successfully getting 0.09. We then receive our fourth mark for correctly working out 0.13 and 0.09. So I'll just put this mark in here, and then we receive our fifth and final mark for having our full Venn diagram as being correct. So in part D of the question, for 2 marks, we're asked to find the probability of the complement of the union of B and C. So we know that the union of B and C is going to be everything in B and C. So if we look back at our diagram here, our Venn diagram that we've drawn, we know that the union of B and C is going to be everything that is contained within B and C. So we know that the complement of this is going to be everything else out with of what is in B and C. So we can see in our diagram here that everything out with of this is going to be 0.22 and 0.22. So writing this down, we have that the probability of the union of B and C complement will be everything that is not part of B and or C. So therefore, from our diagram above, we have that the probability of the union of B and C complement is going to equal 0.22 plus 0.22, which is equal to 0.44. And we have completed the question. There was 2 marks available. So we received 1 mark for having the correct method, so knowing to add 0.22 and 0.22 from our diagram above, and then we get our 2nd mark for having the correct answer, which was 0.44. So we're told that a company sells seeds, and they claim that 55% of its pea seeds germinate. So in the first part of this question, we're asked to write down a reason why the company should not justify their claim by testing all the pea seeds they produce. So having a think about it, we know that if they test all their peas, then they'll have none to sell. And we know that this isn't really best practice for a business because they make money from selling products. So writing this down, we'll say that if they test all their peas, then they will have none to sell. This is not an effective business method, as they can't get any income if they have destroyed all their peas. So this question was worth 1 mark, and we receive our 1 mark for stating that the seeds would be destroyed during the process of checking them, so therefore they have none to sell. So in part B of this question, we're told that a random selection of the pea seeds is planted in 10 trays with 24 seeds in each tray. So we have 10 trays, each with 24 seeds in them. We're asked, assuming that the company's claim is correct, we remember they claim that 55% of its pea seeds germinate, we're asked to calculate the probability that in at least half of the trays, 15 or more of the seeds germinate. So to begin, why don't we say that S is the random variable, which is the number of seeds out of 24 that germinate. We're going to have a binomial distribution. We know this because we have a repeated number of trials. So we have 24 seeds, so that's doing something 24 times. So we can therefore say that S is going to be binomial distributed, and we know that N is going to equal 24, and the probability P is going to equal 0.55, and this is because the company claims that 55% of its pea seeds germinate. So therefore our binomial distribution will be 24, and the probability is 0.55. So then we've now covered the 24 seeds in each tray, but we also have 10 trays. So we're going to let T be the random variable, which is the number of trays with at least 15 or more seeds germinating. So we'll therefore have that T as binomial distributed, and N is going to be equal to 10 this time because we have 10 trays, but we don't yet know the probability because we need to use our random variable S to work this out. So let the probability be Q, and we'll work Q out in a minute. So we'll now work out the probability Q. So Q is going to be equal to the probability. So we're asked in at least half of the trays, 15 or more of the seeds germinate. So 15 is our key number here. So we have the probability that the number of seeds germinating is going to be greater than or equal to 15. And remembering that we have N equal 24 and P equals 0.55, this is going to equal, and we can either do this in our calculator or refer to a binomial distribution table. This is going to be equal to 0.299. And then what we need to do, we'll then have that T is going to be binomial distributed. It still has 10 trials, and we now know what Q is, so we can put that in. So it's going to be 2.99, and then we're asked if at least half of the trays, so that means we have at least 5, so we want to work out the probability that the number of trays is greater than or equal to 5, and again with N equals 10 and probability is 0.299, we put this into our binomial calculator or look at a binomial distribution table, and this comes out to 3 significant figures at 0.149, and this is our final answer. So therefore the probability that in at least half of the trays 50 or more seeds germinate is 0.149. This question was worth 3 marks, and we receive our first mark for knowing to set up both of our variables. So when we've set up our random variables, and particularly the key piece here is knowing that Q is the probability which we need to work out using the random variable S. So we received a second mark for working out what this probability Q was equal to, and we get that mark here. And then we receive our third and final mark for correctly working out the answer, which was 0.149. So in part C of the question, we're asked to write down 2 conditions under which the normal distribution may be used as an approximation to the binomial distribution. So from our knowledge of binomial distributions and normal distributions, there is 2 main points that we can make here. So the first one is that n is large, and the second one is that p, so that's the probability, must be close to 1/2. So therefore that is 2 key points which we must say to get our mark. So we get our 1 mark there for making these 2 points. Summing this up, there are 2 conditions that must be met where we can use a normal distribution to approximate the binomial distribution, and that is when n is large or when our probability is close to 1/2. So for part D of this question, we're given some further information. We're told that a random sample of 240 pea seeds was planted, and 150 of these seeds germinated. We're to assume that the company's claim is correct, so that claim was that 55% of the pea seeds germinate, and we're to use a normal approximation to find the probability that at least 150 pea seeds germinate. So we're going to have the random variable x, and it is going to be the number of seeds which germinate. So it is going to be a normal distribution, and it is going to have mean mu and variance of sigma squared. So we know that when we use this approximation, we have that mu is going to equal n multiplied by p, and our sigma squared, so our variance, is going to equal n multiplied by p multiplied by q. So we have that in this case n is going to be 240, so n is equal to 240. P is equal to, well, that refers to the claim that they made, which was 55%, so P is 55%, and Q is going to be 1 minus 0.55, which is 0.45. So therefore, we can work out that mu is going to be equal to 240 times by 0.55, which is equal to 132, and we'll have that sigma squared is going to be equal to npq, which is going to be 240 times 0.55 times 0.45, which is going to be equal to 59.4. So therefore we've worked out the mean and the variance, so we can rewrite our distribution. So we'll have that x is normally distributed with mean of 132 and variance of 59.4. So before we then go on to work out this probability, we note that we must use the continuity correction. So when we work out our probability, we subtract 0.5. And this is something that we know that we're to do when we are using a normal approximation, and this is just part of the process. So we're going to take a little further look at why we have to use this continuity correction. We know that when we have discrete data, we can approximate this to a continuous distribution, but to make this approximation, we have to take into account the continuity correction. And relating this back to our question, we know that the binomial distribution is discrete, and we then use our continuity correction to approximate it to a normal distribution, which we know is continuous distribution. So we have for our binomial distribution that x is greater than or equal to 150. We then apply our continuity correction, so we subtract 1/2, and this gives us that x is greater than or equal to 149.5. So we therefore have that the probability of x being greater or equal to, we were asked originally to work out with 150, but we're to subtract a half, so we'll have 149.5. Then using our z-score, this is going to be the probability that z is going to be greater or equal than 149.5. Then we take away the mean mu, which is 132, and then we divide by the standard deviation, which is the square root of the variance. So that will be the square root of 59.4. And then we put this into our calculator. So this comes out as z greater than or equal to 2.27. And then we can use our calculator or check a normal distribution table. And we have that the answer to this is 0.0116 to 3 significant figures. And therefore we have completed the question, and we've worked out that the probability that at least 150 PCs germinate is going to be 0.0116. This question was worth 3 marks, and we receive our first mark for getting our distribution into this form here. So by working out the mean and the variance. We then receive our second mark for knowing to use z-scores when we get to this stage here, where it's in a form where we can almost use a calculator to find it out. And then we receive our third and final mark for having the correct answer, which was 0.0116. So in part E of the question, we're asked to use our answer to part D to comment on whether or not the proportion of the company's PCs that germinate is different from the company's claim of 55%. So our probability from part D was 0.0116, and this is a very small number. So this small number tells us that there is evidence to suggest that the company's claim is incorrect. Therefore, we've completed this question and receive our 1 mark for having this correct statement here, which explains that we have a small probability, which means that the company's claim is incorrect. So in this question, we're told that at t seconds, where we have a positive t, a particle p moves, so that its acceleration, which is denoted by the vector a, and measured in meters per second, is given by the following equation. So we have that the acceleration vector is going to be 5t with the I component and negative 15t to the power of a half in the j component. We're given some further information. We're told that when the time is equal to 0, the velocity of the particle is 20 I meters per second. And what we're being asked to do is we're being asked to find the speed of the particle p when the time is equal to 4. So we first note we're dealing with vectors until the final point where we're asked to find the speed. And we know that we'll work with vectors right through the question, and then at the end we can use the velocity vector and find the magnitude to find the speed. But we'll come on to that later, and for now we're going to have a think about how we can go from our equation with acceleration into an equation in terms of v. So we know that if we have displacement, we can follow this arrow here and differentiate once to find the velocity, and then differentiate for a second time to find the acceleration. So therefore, we also know that if we have the acceleration, we can find the antiderivative. And how do we do this? We do this by integrating. So therefore, to go from acceleration to velocity, we can integrate. So therefore, writing this down, we can integrate our equation for acceleration in terms of t to find an expression for the velocity. So therefore, we have, just rewriting it, we have our equation a is equal to, so we'll call it a is actually a vector, and it is going to be equal to 5t, that's the I component, and then the j component is minus 15t to the power of a half. So we can first integrate both these terms separately. So we have that the integral of 5t with respect to t is going to be equal to, so we add 1 to the power and divide by the new power, so that is going to be equal to 5t squared over 2. And then we also have that the integral of 15t to the power of a half with respect to t is going to be equal to So we add 1 to the power, so that'll be 15t to the power of 3 over 2, and then we divide by 3 over 2, and this comes out as 10t to the power of 3 over 2. So therefore we have that the integral of 5t minus 15t to the power of a half integrated with respect to t is going to be equal to 5t squared over 2, and that's still our I component, and then we subtract our j component, which is going to be 10t to the power of 3 over 2, and that's in the j component, and we now must add c, our constant of integration. So once we've added c, we know that this is our expression for velocity. But we're not there yet, so we now need to work out what c is. So we're told that when t is equal to 0, the velocity is equal to 20i. So therefore, we can substitute these values in, and we have that 5 lots of 0 squared over 2 in the I direction, minus 10 lots of 0 to the power of 3 over 2 in the j direction, plus c is going to be equal to, well, 20i. So therefore, computing this, we have that the zeros make these disappear, so we'll then be left with c is equal to 20i. So therefore, we can now take this value of c and rewrite this expression here. So we'll have that the velocity is going to be equal to 5t squared over 2, and then we subtract 10t to the power of 3 over 2, and we now add on c, which is 20i. And remember, these are in terms of I and j also. So then now we're asked to find the speed of p when t is 4. So when t equals 4, we need to find the velocity first. So therefore we can do this by substituting in t equals 4 into this equation. So we'll therefore have that the velocity is going to be 5 lots of 4 squared, and we divide that by 2, and that still remains our I component, and we'll then take away 10 lots of 4 to the power of 3 over 2, and we then add on 20 in the I direction. And plugging all this into our calculator, this leaves us with 40i minus 80j, and then we have 20i. So therefore, we can tidy this up, and we can combine our I components. So we'll have 40 add 20, which gives us 60i, and then we have our negative 80j. So that is our expression for velocity. So that's our velocity expression for t equals 4. We can now find the speed by working out the magnitude. And we do this because speed is the scalar equivalent of velocity. So therefore we have that the speed is going to equal the magnitude of the vector v, which is going to be 60 squared, and then we add on negative 80 squared, and we square root this and put this into our calculator. This comes out as 100 meters per second, and we've therefore found the speed and answered the question. So in this question there was 6 marks available, and we achieve our first mark for knowing to integrate acceleration with respect to time. So when we write our integral here, this is where we get our first mark. We then get our second mark for correctly integrating and adding c. So this is when we had our expression for velocity with c, so that was here. So this is when we had the correct expression for velocity, which included a constant c. We then receive our next mark for working out this value of c, and that was it was 20 in the I direction. We then receive our fourth mark for saying that when t is equal to 4, the velocity vector is equal to 60i minus 80j. So that was just about here we received that mark. And then we received our fifth mark for attempting to find the magnitude. So that's when we did our square root here and then we receive our sixth and final mark for having the correct final answer of 100 meters per second. So in this question we're told we have a rough plane which is inclined to the horizontal at an angle of alpha, where tan alpha is equal to 3 over 4. So we're told that we have a particle of mass m and it is placed on this plane and it is projected up the plane. When the question says projected up a line of greatest slope of the plane, this just means that it is going on the slope as opposed to going above the slope or below the slope. It is moving on the slope. We're then told that the coefficient of friction between the particle and the plane is mu, and we're given some information about its movement. We're told that the particle moves up the plane with a constant deceleration of 4 over 5 g, where g is our gravitational constant. And what we are asked to do in part A, we are asked to find the value of mu. So writing this down, mu, and that is the coefficient of friction. So to help us understand this question better, I'm going to draw a diagram. So firstly, we have our horizontal. So this line here is our ground, and then we're going to have our slope. So we have our slope here, and then we're going to fill our information in. So we know that this angle here is going to be alpha. And then we're told, just in the interim, that tan alpha is equal to 3 over 4. And we can easily work out cos alpha and sine alpha by drawing right angle triangle. So if we draw our right angle triangle just like this, we'll have that our right angle is there and alpha is here. We know that from SOHCAHTOA, just write that out so we remember that, SOHCAHTOA. We have that for tan it is going to be O over A, so we can say the opposite is 3 and the adjacent is 4. So filling that into our diagram, we have 4, which is A, and the opposite is 3. And then we know that H, we can use either the rule of the 3, 4, 5 triangle or Pythagoras to work out that this H is going to be 5. So we can therefore say that for cos alpha, we have A over H, which is going to be 4 over 5. And then for sine alpha, we're going to have over H, which is going to be 3 over 5. So this is going to become useful later in the question, and we'll now go back to filling in our diagram. So I'm going to draw in a box, which is going to be, in our case, our particle, and this is just going to make things easy to visualize. So we know that there's going to be a downward force, and that is going to be gravity. And this is going to be the mass of the particle multiplied by a gravitational constant. And then we're going to have a perpendicular force, which is upwards from our box there. So write in perpendicular, and then we will have our parallel force here as well as friction. So writing that down, we'll have parallel plus friction. So we can see here also that our box is going to be moving here. So the movement is in this direction upwards. It is still moving upwards, but we do know it is decelerating at a rate of 4 over 5 g. So then the next step for us is going to be to write some equations out. So we know the perpendicular force. Let's call this F1. So we're going to have that our perpendicular force F1 is going to be equal to mg cos alpha. And then we know that our force F2, so let's call F2 to be the downward force, so call that F2. So that is going to be friction plus the parallel force. So therefore, we can use the information we have to further our ideas of our two forces F1 and F2. So we know that F1, we don't know m, but what we do know that cos alpha is 4 over 5. So we'll have the first force here, denoted by F1, is going to be 4 over 5, multiplied by mg. And then we know that we can write friction as mu multiplied by our perpendicular force, so mu F1. And then we know that our parallel force is going to be mg sine alpha. And then we can do the same here. We can rewrite F1 in here, and then we can also replace sine alpha with 3 over 5. So we'll then have mu lots of 4 over 5 mg, and then to that we're going to add sine alpha, which is 3 over 5 mg. So the next step for us is going to be to equate these. So we know that 4 over 5 mg is going to be equal to mu multiplied by 4 over 5 mg, and then we add 3 over 5 mg. So then we can see here we have mg, 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 so they all cancel out. So we'll write that in here, mg cancels out, and that therefore leaves us with something that's slightly simpler. So we'll have 4 over 5 is equal to 4 over 5 mu plus 3 over 5. And then therefore we can then rearrange this for mu. So we'll have that 4 over 5 mu is going to be equal to 4 over 5 minus 3 over 5, which is going to be then equal to 1 over 5. And then therefore mu is going to be equal to 1 over 5 multiplied by 5 over 4. Then this comes out, we see our 5's cancelled, which means that mu is going to be equal to 1 over 4. So therefore we've worked out mu, the coefficient of friction. This question was worth 6 marks, and we receive our first mark for knowing that our perpendicular force was equal to mg cos alpha. And then we get our second mark for being able to work out the parallel force. We then get our third mark for equating these two forces. We then get our fourth mark for knowing to use that the friction was equal to mu multiplied by the perpendicular force. So we'll just add that one back in there. And then we receive our fifth mark for producing an equation in terms of mu and knowing to solve for mu. And then we receive our sixth and final mark for concluding with the correct answer that mu is equal to 1 over 4. So in part B of this question, we're told that the particle comes to rest at the point A on the plane. And we're asked to determine whether the particle will remain at A, and we're to carefully justify our answer. So we're just going to redraw our diagram. So we'll have our horizontal here, and then we have our slope, as you can see here. We know that angle is still alpha. And we now have our box is going to be here. I'm not going to annotate it in as much detail as before, but this time we know that when the box is at rest, friction will push upwards and our parallel force will push in the other direction. So that's our parallel force. So we'll just note that down. At rest, friction will be in the upward direction. So then basically what we need to do is we need to compare the friction and the parallel force to see which one is going to be greater. And then from this we can see, will it remain at rest or will it move in some direction. So we know that the friction is going to be equal to mu multiplied by our perpendicular force, which is mg cos alpha. And we know that mu is 1 over 4, and we know that cos alpha is 4 over 5, so we'll have 1 over 4 multiplied by 4 over 5 mg, and that is going to be equal to 1 over 5 mg. And then we have that the parallel force is going to be equal to, and the same as the previous question, mg sine alpha. And we know that sine alpha is equal to 3 over 5. So we have 3 over 5 mg. And therefore we can see that we now have two terms which you can compare. So we have that 3 over 5 mg is going to be greater than 1 over 5 mg. So therefore we can see that the parallel force is greater than the friction. So writing this down, we have that parallel force is greater than the frictional force. So therefore the particle will start to move down the slope and it won't remain at A. So in this part of the question there was 2 marks available, and we received our first mark for comparing our frictional force with our parallel force, and we then received our second mark for using this comparison and coming to an appropriate conclusion, and that was that the particle will no longer remain at the point A. So in this question, we're given some information which says that I and j are both horizontal unit vectors which are due east and due north respectively. So this means that when we're dealing with the I vector, it is to do with moving east, and when we deal with the j vector, it is to do with moving north. And we're told that a radial controlled model boat is placed on the surface of a large pond. We're told that the boat is modelled as a particle, and at time 0 the boat is at the fixed point O and it's moving due north, so it's moving in the north direction with a speed of 0.6 meters per second. We're then told that relative to O, so its fixed point, the position vector of the boat at time t seconds is r meters, where r is a vector. That's our vector for displacement. We're then told at time t equals 15, the velocity of the boat is 10.5 I minus 0.9 j meters per second. And we're told that the acceleration of the boat is constant. And what we're asked to do in part A of this question is to show that the acceleration of the boat is this value here. So 0.7 I minus 0.1 j meters per second squared. So what we want to do, we want to find the acceleration from t equals 0 to t equals 15. So how do we do this? So we can use our equations of motions. So we'll first write down all of our variables. So we have displacement, initial velocity, we have acceleration, and we have time, which is a scalar. So then going through these one by one, here we don't use the displacement, and we know that the initial velocity is 0.6. So we're told the speed is 0.6 meters per second, and we're told it is moving due north, which means that this will be in the j direction as it's going north, and this is what we're told at the start. So that'll be 0.6 j meters per second. Then we have that the velocity, we're given that t equals 15, which is going to be 10.5 I minus 0.9 j, and that is in meters per second as well. We need to work out the acceleration, and we have that our time is 15 seconds, and that's a scalar. So then what we can do, we can use this information to decide what equation of motion we're going to use, and we are going to use v is equal to u plus at. So now what we can do is we can substitute our values in. So we'll have that 10.5 I minus 0.9 j is going to be equal to 0.6 j plus 15 lots of the acceleration, and that's what we're trying to find out. So then what we can do now is we can tidy this up and rearrange for A. So the first step of that is going to be saying that we take away 0.6 j from both sides. So we'll have 10.5 I, then we'll take away 0.9 j, and we'll take away 0.6 j, which is equal to 15 A. And then we can combine these two terms because they're both in terms of j. So we'll have 10.5 I, and then 0.9 minus 0.6 is minus 1.5, and we keep our j, and that is equal to 15a. So then all that's left for us to do is to divide both sides by 15, and we have that 10.5 divided by 15 is going to be 0.7, and that is in terms of I, and then we take away 1.5 over 15, which is equal to 0.1, and that's in terms of j. And therefore we have completed this question, and we have shown the required acceleration value. We look back at the question, 0.7 I minus 0.1 j, and then we have that is in meters per second squared. So then in part B of this question, we're asked to find r in terms of t. So writing this down, we want to find r in terms of t. So this means that we want to have an equation for r, but it needs to be in terms of t. So how are we going to do this? So we're going to use another equation of motion. So we have r, and we want to find that, and then we have that u is going to be equal to 0.6 j. We have that the end velocity is going to be equal to the same as above, so 10.5 I minus 0.9 j. And then we have that the acceleration, well, we've just worked it out, so that's going to be 0.7 I minus 0.1 j, and then we want to have an equation with time in it because we want to express r in terms of t. So it's important that when we choose our equation of motion that we choose one which has both t and r in it. So therefore we're going to select the equation of motion such that r is going to be equal to ut plus 1/2 of at squared. So as we can see here, we have an equation which has r, our displacement, it has t, and then we also have u and a. So this means we can work out an expression for r in terms of t. So all we need to do now is substitute our values in. So we have 0.6 j multiplied by t, then we add 1/2 of our acceleration, which is 0.7 I minus 0.1 j, and we multiply that by t squared, and therefore we've completed the question as we have an expression for r which is in terms of t. So then just looking back at part A of this question, this part A of this question is worth 2 marks, and we receive our first mark for knowing to use the equation of motion and substituting our values in. So we get our first mark at this stage here, and we then receive our second mark for getting the correct answer. Then in part B of this question, this is also worth 2 marks, and we receive our first mark for selecting the correct equation of motion, and we receive our second mark for getting the correct answer. So here in part C of the question, we're told to find the value of t when the boat is northeast of O. So we know when the boat is northeast of O, the vectors I and j will be equal in magnitude, and this is in the expression for the displacement r. So we have that the vectors I and j will be equal in magnitude in the expression for displacement. So therefore, what we can say, we know that our expression for displacement is that r is equal to 0.6 jt plus 1/2 of 0.7 I minus 0.1 j multiplied by t squared. So just running through what the aim here is, we want to get this into a form where we can then set our I components equal to our j components. So to do this, we're going to have to expand these brackets and then take out a factor of t, which is then going to let us make our vectors equal, and we can solve for t. So therefore, we're going to have that this is going to be equal to 0.6 jt plus, we're going to do the factor of a half first. So we'll have half of 0.7 is 0.35 I minus 0.05, half of 0.1, 0.05 of j t squared, and then that is going to be equal to 0.6 j multiplied by t plus 0.35 I multiplied by t squared minus 0.05 j multiplied by t squared. So then remember, this is still our vector for displacement. We're going to take out a common factor of t, and that's going to leave us with 0.6 j plus 0.35 I multiplied by just 1t because we've taken the common factor out, and then again we're going to have 0.05 j multiplied by t. And now what we can do is we can set our I components equal to our j components. So we're going to take our j component 1 and our j component 2 and set them equal to our 0.35 component there. So we're going to have 0.6 minus 0.05 t, and that is going to be equal to 0.35 t. And we'll just write in where this side is our I component and this side here is our j component. So then what we're going to do is we're then going to solve this for t. So we'll have that 0.6 is going to be equal to 0.4t, which implies that t is going to be equal to 0.6 over 0.4, which is equal to 1.5, and we're dealing with seconds, so 1.5 seconds, and therefore we've completed the question. This question was worth 3 marks, so we receive our first mark for equating the I and j components of r. So we'll put that in when we explained how we're going to do that here. We then receive our second mark for doing this, and we then receive our third and final mark for getting the correct answer of 1.5 seconds. In part D of this question, we're asked to find the value of t when the boat is moving in the northeast direction. So this is similar to part C, and what we want to do is to equate the I and j components of the equation for velocity. So we know that the vector velocity is going to be equal to u plus at, and we know this equation from earlier on, so we have that the velocity is going to be equal to 0.6 j plus 0.7 I minus 0.1 j, and that's all multiplied by t. So now, in the same way as the previous question, we want to set the I and j components of v equal to each other. So therefore, what we're going to say is we're going to say that v is equal to 0.6 j, and then we need to expand the bracket again to take our t term into both parts. That'll be plus 0.7 I t minus 0.1 j multiplied by t, and therefore we're now going to again take our j components and make them equal to our I components, and this is just exactly the same method as the previous part of the question. So we'll therefore have that 0.6 minus 0.1 multiplied by t is going to be equal to 0.7 t. Then rearranging this, we have that 0.6 is going to be equal to 0.8 t, so therefore we'll have that t is going to be equal to 0.6 over 0.8, which is 0.75 seconds. And then in this question we get our first mark for knowing to use this equation for velocity and then substitute our values in. We then get our second mark for knowing to and following through with equating the I and j components of the vector at v, and then we receive our third and final mark for working out that t is equal to 0.75 seconds, which was the correct answer. So in this question we're given quite a lot of information, so we're going to work through it slowly and then we'll begin with the question. So we're told that a uniform ladder of length 2a and weight W has its end A on a rough horizontal ground. So we can see here that this is the ladder, which I'm highlighting now in red, and we're told that the coefficient of friction between the ladder and the ground is 1/4, and we're told that the end B of the ladder is resting against a smooth vertical wall, and we can see this here. So this is our smooth vertical wall being highlighted now, and that is where our ladder is lying against it. We're told that a builder of weight 7W stands at the top of the ladder. So he is here, and to stop the ladder from slipping, the builder's assistant applies a horizontal force of magnitude P to the ladder at A. The force acts in the direction which is perpendicular to the wall. So we know that this is acting like that, given the wall is that way. We're told that the ladder rests in equilibrium in a vertical plane perpendicular to the wall and makes an angle alpha with the ground where tan of alpha is equal to 5/2. We're told that the builder is modelled as a particle and that the ladder is modelled at a uniform rod. So in part A of this question, we're asked to show that the reaction of the wall on the ladder at B has magnitude of 3W. So here we're dealing with moments. So we know that at point A, we have a pivot point. So we have a pivot point here, and then there are multiple forces acting this way and all sorts of ways, but they're all in equilibrium given that there is no movement. So writing this down, at point A we have a pivot point and there are multiple forces on A. And they are all in equilibrium since there is no movement. So what we're going to do is we're going to annotate our diagram. So we know from the fact we have that this side is to do with the tan alpha, we have that our ground, that is going to effectively have length of 2a cos alpha, and then our wall is going to have 2a sine alpha, that's going to be its length, and we know that the builder is here, so I'll just draw a particle in there for our builder, and we know that his weight is 7W down. So this is going to be along this line here, so we'll draw our arrow in, so that's going to be 7W, and then we have the weight is also going to be from the middle of this rod, and that's because of the way it's spread out, So in practice, the weight from the ladder is coming from the middle. So that is 1W. Then we know we're going to have this force here, which is the force from the builder. So we'll call that F1 and just annotate it. Force from builder. And then we'll have an equal and opposite force in the other direction. And let's call this F2. So we're then going to take the moments about A. And we know that since all the forces are in equilibrium, their sum will add to 0. So therefore, we will summarize what three forces we have. So we have the builder, we then have the weight of the ladder, and we have the pushback force. So therefore, we can then write out an equation. So we know that the weight of the builder is going to be equal to 7W multiplied by 2A cos alpha. And then we have the weight of the ladder, which is going to act horizontally. That is going to be WA cos alpha. And we only have 1A as we know that the length is halved. So then 2A over 2 is just A. And then we have that the pushback force is going to be equal to S, which is the force we are trying to find. So the reaction of the wall on the ladder at B. That is going to be equal to S multiplied by 2A, and this time it's the sine alpha because it's acting vertically. And we know that all of these add to 0. So we can then manipulate these slightly. So we can multiply the constants here. So we have 7 multiplied by 2, which is 14WA cos alpha. And we add that to WA cos alpha. And we still subtract 2SA sine alpha, which is equal to 0. And then we can combine these two terms because these are the same. So that will give us 15WA cos alpha. And then what we can do is we can add 2SA sine alpha to both sides. So we'll have 2A multiplied by S multiplied by sine alpha. We then see we have an A here, an A here. So we can divide both sides by A, which is going to leave us with 15W multiplied by cos alpha. And that's going to be equal to 2S multiplied by sine alpha. Then what we can now do is if we divide both sides by cos alpha, we'll have that 15W is going to be equal to 2S multiplied by sine alpha over cos alpha. And we know that tan of alpha is equal to 5 over 2. And we also know that tan alpha is equal to sine alpha over cos alpha from our trig identities. So therefore, we can now say that 15W is going to be equal to 2 multiplied by S multiplied by this value here, 5 over 2. And then that gives us that 15W is going to be equal to 2 multiplied by 5 over 2, which is 5. So 5 multiplied by S. So therefore, we can then divide both sides by 5. And that gives us that the force S, which is the reaction of the wall on the ladder B, we will have that it is going to be equal to 15 over 5, which is 3W. And therefore, we've completed the question as this was what was required. This question was worth 5 marks, and we achieved our first mark for taking the moments about A. So that's here where we achieved that. We then achieve our second and third mark for having this expression here. So 7W 2A cos alpha plus the rest of that, we receive not 1 but 2 marks at this point. We then receive a third mark for making use of tan alpha to substitute that in for sine alpha over cos alpha, and then we receive our fifth and final mark for concluding with the required answer, which was 3W. So in part B of this question, we're asked to find the range of possible values of P for which the ladder remains in equilibrium. So we recall that P is a horizontal force which is applied to stop the ladder from slipping. So we know that there'll be two components to this. We'll first have the perpendicular force. So we know that this is everything that's moving perpendicular to the force P. So this is going to be the weight of the builder and the weight of the ladder. So this means that it is going to be 1W plus 7W, which is 8Ws. And let's just denote this as F1. And then we know that the friction is going to be mu multiplied by F1, and we're given in the question that mu is equal to 1 over 4, so we'll have 1 over 4 multiplied by 8, which is equal to 2W. So therefore, we now can work out the max value of P and the minimum value of P, where we will have our friction going for and against the movement. So we will, for the maximum, we will add 2W, and for the minimum, we'll take away 2W. But what do we add and subtract these from? Well, we will use the force, which is the reaction of the wall on the ladder. And we had that from part A, and that was 3W. So we'll just annotate this in here. So we had that 3W comes from part A of the question. So then, therefore, we know that this is going to be 5W, and the minimum will be 1W, which is equal to just W. So therefore, we can state the range. So the range of values of P will be, they're going to be W, P, and 5W. So therefore, the range of possible values are going to be P between 1W and 5W. In this question, there was also 5 marks available, and we received our first mark for calculating 8W here. We then received our second mark for calculating the friction force. We then received our third and fourth marks for correctly calculating the maximum and minimum value for P. So that was 5W and 1W. And then we received the fifth and final mark for correctly working out the range and stating it in a range form like this. So in part C of this question, we're told that often in practice, the builder's assistant will simply stand on the bottom of the ladder. And we're asked to explain briefly how this helps to stop the ladder from slipping. So we know that by taking the moments of A, the reaction of B will be unchanged, so nothing will be affected from that end. So we'll just write that down. By taking moments at A, the reaction on the ladder at B is unchanged. So then secondly, we can say that there will be more weight on the ladder, which means that the perpendicular force will increase. So writing that down, we will have more weight on the ladder, so the perpendicular force will increase. And then in turn, we know that the friction relies on both the friction coefficient and also this perpendicular force. So therefore, since, and then if we denote this perpendicular force as F1, let's say since F1 increases, friction will increase, since the friction is equal to this perpendicular force F1 multiplied by the coefficient mu. In this question, there was 3 marks available, and we received 1 mark for each bullet point we state here. Our second mark here, and then we receive our third mark for this third bullet point there. So in this question, we're told that a boy throws a stone with speed u meters per second from a point O at the top of a vertical cliff. We can see on the diagram our point O is here, and we see that it is 18 meters above sea level. We're told that the stone is thrown at an angle alpha above the horizontal, where tan alpha is equal to 3 over 4. So we see that alpha is this angle in here. We're then told that the stone hits the sea at the point S, which is a horizontal distance of 36 meters from the foot of the cliff. So we can see here that this is the point S on the diagram, and that is our 36 meters from below where the stone is thrown. We're told that the stone is modelled as a particle and it's moving freely under gravity with g equal to 10 meters per second squared. And what we're asked to do in the first part of the question is to find the value of u. So u is the speed that the stone was thrown at. To start off, we're going to just note down that u is the initial velocity that the stone was thrown at. So we're given that tan alpha is going to be equal to 3 over 4. So therefore, we can use our knowledge of trig to work out what cos alpha and sine alpha are, as this is going to be very useful as we proceed with the question. So as you can see here, I'm going to draw a little triangle in. We have a right angle here, and if we let this be alpha here, we know SOHCAHTOA, and therefore we can say that tan alpha is going to be O over A. So we have that this is A, O, and H. That's our three sides. So we have that in from the information we're given, tan alpha is equal to 3 over 4. This means, looking at SOHCAHTOA here, that 3 will go here and 4 will go here. Then using Pythagoras, we see that the hypotenuse will be 5. So therefore, we can say that cos alpha is going to be equal to A over H, which is 4 over 5. And we have that sine alpha is going to equal O over H, which is 3 over 5. So this is very useful, and this is going to help us as we move forward with the question. So what we can do now is we can split the motion of the stone into its vertical component and its horizontal component. By looking at both the horizontal and vertical components of the motion, we can then use these to work out the initial velocity u. We do this by solving the horizontal component for t, which will be in the form of an expression in terms of u, and then following on from this, we can use this value of t, which is in terms of u, in our vertical component equation, and we'll then be able to rearrange that for u, and that's what we're going to go ahead and do now. So how are we going to do this? So for the horizontal component, we're going to write out our variables and have a look at what we have. So we know we have suvat. So we want to find the time, and that's going to be useful to help us in the next stage. We know that the displacement is 36 meters, and the initial speed is going to be u multiplied by cos alpha. And we also have that the acceleration is equal to 0 meters per second squared. And this is going to be all the things that we need to take forward for just now. So we are going to use the equation that S is equal to ut. So then 36 is going to be equal to u cos alpha multiplied by t. And we can then substitute in, because we know that cos alpha is equal to 4 over 5. So we'll then have 36 is equal to 4 over 5 multiplied by ut. And then what we can do is we can rearrange this for t. We then divide both sides by 4 over 5, which gives us that 45 is equal to ut. So therefore we have that t is going to be equal to 45 over u. And then taking a look at the vertical component, we'll write out our suvat again. So this time we know that the displacement is going to be negative 18 meters. We're going to have that u is going to be equal to u sine alpha, which is going to be equal to u multiplied by 3 over 5. At this point, don't know v, and then we know that the acceleration vertically is going to be negative 10 meters per second squared, and this is our value of g, and then we do not know the time either. But what we can say is that we have an expression for the time in terms of u, which we worked out here. So therefore, we're going to use the equation S is equal to ut plus a half at squared. So now we're going to substitute our values in. So we have that the displacement is equal to negative 18, and then we have that u is equal to 3 over 5 u, and we multiply that by 45 over u. So then in a second we're going to see that our u's cancel out, but carry on for now, we then add on 1/2 of negative 10 and then 45 over u squared. So if we're tidying this up a bit, we'll keep our negative 18 on one side, and then we'll have that our u's cancel out, and then we'll have 3 over 5 multiplied by 45, which is going to be equal to 27, and then we have 1/2 multiplied by negative 10 multiplied by 45 squared, and that's going to be equal to negative 10,125. So we have negative 10,125, and we divide that by u squared. So then all that's left for us to do now is we rearrange for u. So we'll have that 10,125 is going to be equal to 45 u squared, and then we divide both sides by 45 and take the square root. So we therefore have that u is going to be equal to 10,125 divided by 45, and we take the square root of that and put this into our calculator. This comes out as 15 and the unit is meters per second. So therefore we can conclude that u is equal to 15 meters per second. So in this question we received our first mark for using the equation S is equal to ut. We then received our second mark at this line here, where we substituted in the values correctly. So we knew that the horizontal displacement was 36 and that the initial velocity u can be written in terms of u multiplied by cos alpha. We then received our third mark for using the next equation of motion. So when we use S was equal to ut plus a half at squared. We then received our fourth mark for getting to this stage here where we substituted our values in. We then get our fifth mark for knowing to use this value of t in this equation here. So we'll just put a second circle here and then receive our sixth and final mark for having the correct answer in the end. So in part B of the question, we're told to find the speed of the stone when it is 10.8 meters above sea level, and we're to give our answer to two significant figures. So this question is quite similar to the previous question in the fact that we have to break it down into vertical and horizontal components. So if we can find both the vertical and the horizontal velocities, and then since these are vectors, each with a horizontal and vertical direction, we can then find the magnitude of this vector, which will give us the actual speed at this point. So therefore, starting off with the vertical component, we have this time, so the displacement, so we know the stone started at negative 18 meters, and then we now want to find the distance it's travelled when it's 10 meters above sea level. So therefore we add 10.8. So therefore this is going to be equal to negative 7.2 meters. We have that our value of u. So this is going to be our initial speed, which we've just worked out in part A, multiplied by sine alpha, since it's the vertical component. So that is going to be u sine alpha, which is equal to 15 multiplied by 3 over 5, which is equal to 9 meters per second. Then we don't know the velocity, that's what we're trying to find out, and we know that the acceleration is negative 10 meters per second squared. So therefore the equation we're going to use to work out the velocity, is going to be v squared is equal to u squared plus 2as. So therefore, summing values in, we're going to have 9 squared plus 2 lots of negative 10 multiplied by negative 7.2. And then putting this into our calculator, we have that v is going to be the square root of 225. So therefore, we have that v is going to be equal to 15 meters per second. And then for the horizontal component, we can just use the equation v is equal to u cos alpha, and that's going to be equal to 15 multiplied by 4 over 5, which is equal to 12 meters per second. So therefore we can go from two vector components of velocity to a scalar, which is speed, by finding the magnitude of the velocity vector. So therefore we have that the speed is going to be equal to 15 squared plus 12 squared, and then we square root this, and putting this into our calculator, this comes out as 19.209 and so on, and we're asked to find this answer to two significant figures. So we'll conclude that the speed when the stone is 10.8 meters above sea level will be 19 meters per second. So in this question there was 5 marks available. We receive our first mark for using this equation here to work out our horizontal component. We then receive our second mark for using this equation here with the correct values to work out our vertical velocity, and we then receive our third mark for having the correct vertical velocity. We then receive our fourth mark for knowing to find the magnitude, and then we receive our fifth and final mark for having the correct answer, which was 19 meters per second. So in part C of this question, we're asked to suggest 2 improvements that could be made to the model. So one thing that first springs to mind is that when a stone falls through the air, there's going to be force opposing it, and this is normally known as air resistance. So therefore an improvement to the model could be to take into account air resistance. A second suggestion could be to have a look and see what the wind does and how much of an effect the wind has on the stone. This question was worth 2 marks, and we receive 1 mark for each correct statement we make about an improvement which would be used to improve the model.